Alright guys, so I'm obviously not here to be able to do a review with you. So I'm going to run through this entire chapter and review the high points as we go. You will have a review assignment that you can complete after this, and then plan for a test on Monday or Tuesday, whenever you would see me again. Alright, so Chapter 1, Foundations of Algebra. First thing we talked about was variables and expressions. So first off, what is a variable? So a variable is a symbol, usually a letter that represents one or more numbers. Most times we're using stuff like X, Y, Z, and so on. Those are the most common ones we're going to see. Okay, so variables are used in algebraic expressions. An algebraic expression has just numbers, variables, operation symbols. There's nothing like that. So something like X plus 2, that's a variable or an algebraic expression or a variable expression. Okay, the next thing, if we just compare the two, a variable expression has variables, numeric expression does not have variables. And that's the main difference between these. Notice so far, these are expressions, not equations, so there's no equal signs. Whenever we are writing algebraic expressions, taking them from words into expression format and number format, we have some of those key words. More than is addition, sum means addition, and so forth. Difference or minus or less than, those all mean subtraction. Product or times is going to mean multiplication, and quotient is division. And now again, these two are important. The order matters. These two, order does not matter. All right, so here's just a couple examples of what it looked like. 3 more than n is going to be n plus 3 or 3 plus n, either way. The difference of n and 3 is n minus 3. Be careful with the order here, n and 3. The difference of those two has to be n minus 3. All right, and you can see the rest of those there. I'm not going to go through every one of them because I already taught these lessons. We're just trying to review and hit the high points. All right, so when we have an equal sign makes something an equation. And the big word for equals in a phrase is. Anytime you see the phrase is, that is where your equal sign would go. So if you have something like 4 less than 2 times a number x is 5. Okay, as soon as you see is, that's where your equal sign goes. Less than means minus. 2 times is going to be multiplication. So our equation would look like this. 2 times the number x, 4 less than that, is equal to 5. So then we'd have the equation 2x minus 4 is equal to 5. Next thing we talked about was exponents and order of operations. Order of operations, please excuse my dear Aunt Sally, or PEMDAS. All right, it stands for parentheses and brackets. This is your first step always. All right, those go together, exponents and roots. Don't forget roots in those. That's your step 2. Step 3 is multiplication and division. Step 4 is addition and subtraction. And every time you're within a step, so say you have a bunch of multiplication and division in one step, you have to go left to right. That's how the order of operation works within each step. All right, simplifying means to do whatever operations are there, combine like terms, those types of things. And you want to do each one of those, you want to get it in the smallest terms possible. That's called simplifying. Exponents means this number times itself this many times. The little number up top is called your exponent. The big number is your base. So in this case, we have 2 times 4, or 2 times itself 4 times. It's not 2 times 4. So this is 2 times 2 is 4, times 2 is 8, times 2 is 16. It is not 2 times 4. A lot of people make that mistake. To evaluate, what you have to do is plug a number in for a variable. So I might have x equals 2, and then I have 2x plus 3 minus 4x. So I would plug a 2 in for x each time. 2 times 2 plus 3 minus 4 times 2. Every time I plug a number in, I like to put a set of parentheses first so you don't mess up if there is any negative signs involved in that one. So now order of operations would take over. 2 times 2 is 4, plus 3. Negative 4 times 2 is negative 8. So I have 4 plus 3 is 7, minus 8, which is negative 1. Exploring real numbers, we have the natural numbers, whole numbers, integers. Natural numbers are your counting numbers. They start at 1. Whole numbers, the only difference is it involves 0, whereas this does not. Integers is all your positive and negative whole numbers. Okay, rational numbers, any number you can write in the form a over b, where a and b are integers and b does not equal 0. So this is your fractions and your terminating decimals. So that means a decimal that comes to an end, it doesn't keep going. You also have your repeating decimals. They would fall in here as well. All right. Then we have irrational. Irrational is kind of the ugly one. This is your non-terminating and non-repeating decimals. So those are the really ugly ones. Most often they're ones in the form of like a square root that doesn't come out even. So the square root of 5 would be an irrational number. So we have our whole world of real numbers. Over here is our irrational. Here's our rational. Inside that we have the natural, we have the whole, and we have our integers. That's how they fall together. Natural, whole, integer, rational, irrational, those are all called subsets. Subsets are part of a larger set. Real numbers would be the entire set. Each one of these inside are called subsets. All right, an inequality is just how you compare something, so make sure you're using those correctly. Remember, if you have greater than or less than, the mouth goes to the bigger one. So the bigger one's here in this case, the bigger one would be here in this case. All right, and two numbers that are the same distance from 0 on the number line are called opposites. So a 4 and a negative 4 would be opposites of each other. A negative 6 and a 6 are opposites of each other, and so on. And the absolute value of a number is its distance from 0 on a number line. So anytime you have the absolute value, if I have something like this, it's going to come out as positive. All right. Go to the next half of the chapter. So the next half of the chapter, we had properties of real numbers. But before we go there, let's do a couple warm-up problems. All right, these ones would be involving order of operations and evaluating. So the first one, order of operation, we do inside first. We have 11, 3 times 11 minus 6 times 2. So 6 times 2 would be the next step I need to do, as well as this multiplication here. So 3 times 11 is 33, minus 6 times 2, which is 12. 33 minus 12 is going to be 21. Second one, start inside your parentheses. So we start inside here. Inside here, we do have multiplication. So we have 8, 4 plus 3 times 2, which is 6, minus 4 times a negative 2. I'm going to simplify here. 4 minus 6 is going to be negative 2. So negative 2 times 8 is negative 16. Negative 4 and negative 2 is going to be a positive 8. So negative 16 and positive 8 is going to be negative 8. Down here, I'm evaluating, so I need to plug in my x and y value for each of these. I like to go through first, set of parentheses everywhere that there's a variable, and then plug in. So my x is 8. It would go there and there. My y is negative 2. It would go here and here. Now, order of operation takes over. I've got 3 sets of multiplication, here, here, and here. So 3 times 8 is 24. 8 and 2 is 16. They're both negative, so it's going to turn positive. 8 times -2 is going to be -16. So now these two just cancel each other out, a positive and a negative, they're opposites. I'm left with 24. Last one, I'm going to go through and set all my parentheses first. Small set of parentheses everywhere that there's a variable. All right, plug in my x's first. 8, 8, y and y, so this is going to be -2 and -2. Start inside, work my way out. So 8 plus 2 is what this is going to turn into, so that's 10. So I'm going to have 8 times 10 plus 4 times -2. 8 times 10 is 80. 4 and -2 is -8. So this guy is going to be 72, and that would be my final answer there. All right, so there's some warm-ups from the first half of the chapter. So let's get in the second half of the chapter. So properties of real numbers. There's a big list of properties that we took down. First one is commutative property. We have it for addition and multiplication. Says it doesn't matter the order that you add or multiply, you're going to get the same answer. Now we have the associative property. Associative property is you can move around your parentheses for addition and subtraction. It doesn't matter if you multiply these two first or multiply or add the first two or the second two. It doesn't matter. You're going to get the same answer. Identity properties for addition. If you add 0 to anything, you're going to get the same number that you started with. Identity property multiplication says if you multiply anything by 1, you get the same thing that you started with. Inverse property of addition says if you add a number and its opposite together, you're going to end up with 0. So it'll be like 4 and -4 is going to give you 0. Inverse property of multiplication, if you multiply something by its reciprocal, you're going to get 1. And lastly, symmetric property says if two things are equal, it doesn't matter which one you write first. So if I say x equals 2, then 2 equals x. It goes both ways. All right, so looking at a couple, what properties it's showing. So in the first one, all we did was change the order of the 5 and 3. So if you change the order of something, if we look back, changing the order is the commutative property. So you can have commutative property of, this one is addition, so make sure you put the commutative property of addition. This one is going to be the identity property. Identity property of addition says if you add something and its opposite together, then you're going to get it equal to 0. Yes. Yes. Yeah, that's fine. Okay. I actually will not be here tomorrow. Um, Kim, is it able to take a picture? See if you can take a picture with it and save it in a file and then email it to me. That's another option. And if that doesn't work, have them show it to me on Monday. How about that? Yeah, that'll be fine. And typically I'd say just, bring it down tomorrow morning, but like I said, unfortunately I'm not here tomorrow, so. Yep, not a problem. Bye. All right, sorry about that. Now we're back. So identity property for that one. And then the last one, all we do is move the parentheses. So now we have the associative property. Associative property of multiplication. All right, multiplication. Deductive reasoning is using facts and come to an answer. If something's true or false, make sure you can prove it. You prove it using one example. One example changes the whole thing. All right, so in this case, for all our numbers A and B, all right, this is false. And it is false because you can provide an example. So I'm going to say that A is 3 and B is 4. So 3 times 4 is 12, but 3 plus 4 is going to be 7. Those are not equal to each other, so therefore it's false. This one here is just the commutative property and the associative property put in the same step. All right. Skip over those warm-ups. If you want to use these as practice, I would pause the video right now and go from there. So I'm just going to take 30 seconds here. If you need longer, go ahead and pause. All right, introduction to equations. All right, we have 3 types of equations. We want to simplify each side of the equation and compare them to each other, and that's going to determine whether they're true or false. If it has a variable, it's what's called an open equation because we don't know if it's true or false. At that point in time, we're not sure. So in this one here, I'm going to simplify this side over here. I'm going to have 24 plus 18. So that's going to be 42. Over here, I have 20 and 22. It's going to be 42 as well. Those two are equal, so it is true. Right? Next one, we have 7 times 8. We simplify the left side. 7 times 8 is 57. 56, sorry, 56. This side is 54. Those are not equal to each other. Therefore, it is a false statement. Last one, if you're identifying them, as soon as you see this variable, it is open. All right, it doesn't matter. You don't have to solve it. All right. Next set, again, as soon as you see this, boom, open, done. There's nothing else you have to do. Here, 16 minus 7 is going to be 11. Over here, 4 plus 5 is going to be 9. That would be false. Sorry. Can't do math right now. This would be 9, so they're equal to each other, so it's true. So here, 32 divided by 8 is going to be 4. 2 times 3 is 6. Those are not equal, so it would be false. Solution to equation is a number or numbers that satisfy an equation and make it true. So here it says, is x equals 6 a solution to the equation? 32 equals 2x plus 12. So we have to plug our x value in for x to see if it comes out the same. So 32 equals 2 times 2 plus 12. 2 times 2 is 4 plus 12. It should be 6, sorry. This is 12. 12 and 12 is 24. 32 does not equal 24, so it is not a solution. Okay, looking at the next one, it's 1/2 a solution of this, so I'm going to 6 times 1/2 minus 8 equal -5. 6 times 1/2 is going to be 3, minus 8 is going to be -5. So I have -5 equals -5, so that's true, so it is a solution. Now, if I give you an ordered pair, I have 3 and 10. It says is 3 and 10 a solution of y equals 4x. Remember, if you have an ordered pair, this is x, this is y. So you plug that in. Y is 10, x is 3. 4 times 3 is 12. So they do not equal, so it is not a solution. Last one, we have x is -3, y is 18. So we have 18 equals -6 times -3, positive 18. That are equal to each other, so it is a solution. Right? A couple others want to mention. Covered all this. Let's do, just going to go distributive property here. So remember the distributive property. Let's derivative property says if you have A times B plus C or A times B minus C, it's equal to AB plus AC. Over here, it's AB minus AC. Okay, this only works if I can't simplify something inside. So if I have 4 times 2 minus x plus 3, I would distribute the 4 through. 4 times 2 is 8 minus 4x plus 3. 8 and 3 is going to be 11, combining like terms, minus 4x. Don't forget, if you have something like this, 3 minus x plus 4, even though there's no number right here, there is a negative 1. All right, I have to distribute the negative 1 too. So I have 3 minus x minus 4, combine like terms now. 3 and negative 4 is going to be negative 1 minus x. All right, if you are combining a 2x and a 3x, remember you just add the coefficients together to give you 5x, and the units stay the same. All right, I hope this answers any questions you might have on Chapter 1. We are looking to test the next time you see me, whether it be Monday or Tuesday. There is a review assignment in the book, and there's also some review on Get More Math. So get to work on that now. If you have any more questions, feel free to reach out to me.